Now let's look at this new term, which is conjugate hyperbolas. Of course, there are two hyperbolas which are termed as conjugate. So a conjugate hyperbola is nothing but a horizontal hyperbola which has been transformed into a vertical hyperbola. Then these two hyperbolas would be termed as conjugate hyperbolas, or we can say that this hyperbola is the conjugate of the other. So let's look at what the definition say. A conjugate hyperbola is the hyperbola formed by interchanging the transverse and conjugate axis of the original hyperbola with the same center and asymptotes. Now, I hope you must have understood what the same center means, and asymptotes might be a new term for you. I'll just give you a brief of what asymptotes are. Asymptotes are lines which seem like they are going to touch both the curves of the hyperbola, but they do not. Of course, there are two asymptotes in every hyperbola. We will be looking into the details of asymptotes when we are studying rectangular hyperbola. For the timing, let me just explain it to you. Let's say if this was my hyperbola. So what would be my asymptote be? This line here. Again, it never touches the hyperbola. It just seems like it is going to touch the hyperbola. It is a straight line which passes through the center. So this is these two are my asymptotes. So now I hope you must have understood that. Let's say if this is my hyperbola. Again, this is a horizontal hyperbola. So my vertical hyperbola would become somewhat like this. Now these two can be said to be conjugate if, let's say, this is my transverse axis. Now my transverse axis has been transformed into the conjugate axis. Here it is conjugate axis. And the conjugate axis that was here has now transformed into the transverse axis. So then these two hyperbolas can be termed as conjugate hyperbolas. Now the length of transverse axis that was here, let's say if it was 2a, now the length of conjugate axis would become 2a. And the length of conjugate axis that was here, which was 2b, that has now transformed into the transverse axis length, which has now become 2b. So the equation would also transform a little bit. We will look into an example to explain how the equation transforms. Now for both these hyperbolas, you can see that the center remains same and the asymptotes will also remain same. Let me show this to you. Let's say if this was my x and y axis, and this is one of my asymptotes, and this is one of the other asymptotes. Now I hope you must have understood that for standard hyperbolas, the asymptotes would always pass through the center. Now one of my hyperbolas curves is in this manner, the other one is this. Now the asymptotes never touch, not even they are tangent to the hyperbolas. So this was my horizontal hyperbola and these are the asymptotes. Now if I was to transform this into a conjugate one, what would happen? The hyperbola would go in this format. Again, you can see that the asymptotes never seem to touch my hyperbola. So that is why we say that the asymptotes and the center remains same for conjugate hyperbolas. Now this concept of asymptotes would be used when we are studying rectangular hyperbola in much detail. That time we'll look into it. So for the time being, let's look at an example. Let's say x square by 16 minus y square by 9 is equals to 1 has been provided to you. Now you have to find out the conjugate of this hyperbola. So first let's draw the diagram. This is my center and this here is now 4, 0. This here is minus 4, 0. My b here is 0, 3, 0, minus 3. So this is my transverse axis right now. And this is my conjugate axis. Now if I was to transform this into a conjugate hyperbola, so let us do this by drawing the diagram. This is my hyperbola. So what is this now? Again, the values that were in conjugate have now transformed into the transverse values. That means this would be 0, 3 and this would remain 0 comma minus 3. And here the conjugate the values which were transverse have now transformed into conjugate values, 4 comma 0, and this would be minus 4 comma 0. Now if I was to write down the equation of this, again this is my transverse axis and this is my conjugate axis. Now if I were to write down the equation of this, how would I write it? Y square by 9 minus x square by 16 is equal to 1. So this is my equation. Now if you see, there hasn't been much difference in the equation. The only thing that the coefficient of y square, which was in negative form, has now transformed into a positive one, and the coefficient of x square, which was positive 1 by 16, has now transformed into negative 1 by 16. So that is simply just how you write down the equation of conjugate hyperbolas. Now the one thing that you can find out from here is, let's say if I was to find out the eccentricity of this hyperbola, this would be 1 plus b square by a square. So this can be written as 1 plus 9 by 16, or I can write this as 25 by 16, whose root would make it 5 by 4. Now let us find out the eccentricity of this one. Let us name this E2. Square would become 1 plus b square by a square. So E square would be written as 1 plus, this would now become 16 by 9, and upon solving this you would get a value. And then now how do we find out the relationship between these two values? 1 by e1 square upon 1 plus 1 by e2 square is equal to 1 for two conjugate hyperbolas. Now let us say for this we've gotten the e1 for this hyperbola. Now if I were to find out the eccentricity for this hyperbola, let me use this equation to find it out. 1 by e1 square is what? 25 by 16. So 16 will go up. 1 by e2 square, that is what we have to find, is equals to 1. So 1 by e2 square can be written as 1 minus 16 by 25, which makes it 9 by 25. And how do I write e2 square? This can be written as 25 by 9. So e2 becomes 5 by 3. So this is how the equation of eccentricities for conjugate hyperbolas is written. Again, an important concept you need to remember, because there are a lot of questions in previous year JEE Mains that have been asked based on this equation. Now one more concept that you can remember from here. Now one more concept that you can find out from this conjugate hyperbolas is that the focus and the foci of both these hyperbolas always form a square. So let's say the focus of the first hyperbola would be AE comma 0, and this one would be minus AE comma 0. And when I conjugate it, what would it become? 0 comma AE and 0 comma minus AE. If I was to join this in the form of straight lines, then this would always become a square. So sometimes they might ask you regarding finding out the area of this square. So this is how you can find it. So you can see that this height is nothing but 2 times AE, and this height is also nothing but 2 times AE. So it is a complete square. Now a few important notes that you need to remember. Eccentricity is always written as 1 plus, or instead of this you can simply just remember E square is equal to 1 plus B square by A square, where A is always greater than B, which makes it, gives us the information that A is the transverse axis and B is the conjugate axis. Latus rectum is again 2b square by A. Distance between foci is transverse axis into eccentricity. What is our length of transverse axis, which is 2a into eccentricity E. I hope you all remember the diagram. The focus is AE comma 0 and the other one is minus AE comma 0. That means this distance is AE, this one is also AE, so it becomes 2AE. Distance between directrices, one of the directrix is here, the other one is here. This distance we know is A by E, this is also we know A by E, so it makes it 2A by E, which is exactly what is mentioned here. Now let us look at the standard form of an hyperbola where a center has also been given to you. Again, it is nothing different from ellipse, as we had studied in ellipse that the standard form, there is no changes that we do in the equation. The only thing is x minus h is added and y is written as y minus k. So similarly, that has been shown here. This is how you can write down the standard equation of an hyperbola. If let's say I was to put h comma k as the origin 0 comma 0, so this would transform into our standard equation, which is x square by a square minus y square by b square, which is equal to 1. Now let's look at the parametric equation. Now again, an important thing you need to remember, for circles, if you remember, the parametric equation used to be r cos theta comma r sin theta. For parabolas, if you remember, the parametric equation used to be at square comma 2at. And for ellipse, it used to be a cos theta comma b sin theta. Now for hyperbola, it is nothing but a sec theta comma b tan theta. You have to remember this thing because it is necessary to solve questions. Now if you try to input these values in this equation, of course it would satisfy it. Now let's say if the hyperbola was given with some center. Let's say if this was my hyperbola. Sorry, this is not y square, this is y minus k square by b square is equals to 1. Now let's say if I was to write down the parameters for this, then how would I write it? H plus a sec theta comma k plus b tan theta. If you try to satisfy it, of course k and k would get cancelled, h and h would get cancelled, a square would get cancelled, and sec square theta minus tan square theta, as we had studied in trigonometry, is equal to 1. So this is how the parametric forms of these equations are written. Now let us look at the position of a point. Of course, nothing different from what we had studied in ellipse, parabola. For position of point, we find out, since we know that s of an hyperbola can be written as x square by a square minus y square by b square minus 1. This is how s is written. So we find out s1 when a point is given. Let's say the point is x1 comma y1. We find out s1 by putting the values of x1 here and y1 here, which makes it x1 square comma a square by a square minus y1 square by b square minus 1. And once we found out s1, if s1 is less than 0, point lies inside the hyperbola. And what do I mean by inside? A hyperbola is given, that means the point is lying somewhere here inside. If s1 is greater than 0, it lies outside the hyperbola, which is somewhere here. And if s1 is equal to 0, it lies on the hyperbola. So that is what has been mentioned here. If it is less than 0, it lies inside. It lies on if the equation is satisfied of s1, which is equal to 0. And if it is greater than 1, it lies outside the hyperbola. Now again, the same concepts we will be using for position of line / other conics. I hope you all remember we had studied the same thing in ellipse and parabola, so I wouldn't go into much detail. Let's say a line or other conics equation has been provided to you. So you transform the entire equation into just one single equation to get a quadratic. And from that quadratic, you can find out the discriminant. And from that discriminant, which is of course b square minus 4ac of that equation, if d is greater than 0, you can say that it is cutting or intersecting. The line or the conic intersects. if d is equal to 0, we say that it is a tangent, and if d is less than 0, we say it neither intersects nor touch our hyperbola. Now again, this was for line. Let's say if a conic has been provided to you, and while you transform it into a single variable equation, you get a biquadratic, which is in the form of a 4-degree equation. So you assume that, let's say, x square is equal to t, and if you assume a second degree variable to a single degree variable, you would get a quadratic equation, and from there you can find out the discriminant. And again, the process is same that we had studied in ellipse and parabola.